This is for Year 12 methods. It comes out of 6.6 related rates of change. It's introduction and question number 4 and 7 out of 6.6. Rates of change are where one unit or one variable changes with respect to another variable. The change in distance over the change in time, dx dt, or sometimes ds dt if s represents displacement. The change in volume with respect to radius, dv dt. The change in surface area with respect to the change in height. All of these are rates because distance changes as time changes, two different variables changing, and the rate at which that change occurs is described by that rate. Sometimes, if we have a particular object that might have a three-dimensional aspect, I could talk about the change in volume of the object with respect to time, or I could talk about the change in surface area with respect to the change in time, or the change in radius with respect to the change in time. I could also talk about the change in volume as the radius is changing, or the change in volume as the surface area is changing, or the change in surface area as the volume is changing. All of these different rates are related to this rate because it's about the same cylinder. So these are all different rates that can be generated on the same cylinder. Okay, a couple of examples out of 6.6. Question number 4. The radius of a circular puddle is increasing at a rate of 10 centimeters per hour. So I have a circular puddle. Circular puddle is a circle. It's increasing at a rate of 10 centimeters per hour. It's the radius that is changing. So I have dr dt, it's increasing, so it's going to be positive 10, and that's going to be centimeters per hour. Find the rate at which the areas are increasing when the radius is 1.5. So it's asking for dA dt, the rate at which the area is increasing when the radius is 1.5 meters. Now I've got a variation of units here, so I can use that as being 150 centimeters, or I could talk about that dr dt is equal to 1/10, because 10 centimeters is 1/10, and r equals 1.5, one or the other. Okay, our chain of derivatives connecting this would be dA dt. I've been information about radius, so I'm going to have dr, and I know that's going to equal t. My area equals pi times radius squared because I have a circle. That's one variable only, so therefore I can take the derivative dA dr equals 2 times pi times radius. So it's going to be 2 times pi times radius, which is going to equal 20 pi times the radius, which in this particular case is 20 times pi times 150, which is going to be 3,000 pi. 250 is 300, pi and 10 gives 3,000. 3,000 pi centimeters squared per hour. And if I was over here doing it in meters, then I know that dA dt equals 20 pi times radius. Sorry. I know that dA dt equals dA dr times dr dt, and that's going to be 2 times pi times radius times 1/10, which is pi radius on 5, and when it's going to equal 3 on 2, then it's going to be pi on 5 times 3 on 2, which will be 3 pi on 10 meters squared per hour. And looking at question number 7, a rectangular block of ice is melting at a rate of 2 cubic centimeters per second. So I have a rectangular block of ice. there's my rectangular block of ice, and it's melting, so that dV dt is -2 because it is melting at a rate of 2 cubic centimeters per second. The block has a square base and its height is 3 times its base length. So if that's x, that will be x because it's on a square base, and its height will be 3x because its height is 3 times the base length. Find the rate at which the base length is changing. So you're asked to find dx dt, the rate at which the base length, and I've called that x. My chain of derivatives will be dx and dt down there. I've been given information about volume, so I'm going to have dv, dv. And I know that dv dt is -2. I need a formula or a rule that's going to connect volume to x. So the volume of a rectangular block is length times width times height, which in this case is x times 3x, which is 3x cubed. dv dx is going to equal 9x squared, and I'm interested in dx dv, so dx dv will equal 1 on 9x squared. So 1 on 9x squared, which in this case is -2 on 9x squared. That's the rate at which x is changing with respect to t. But I've been asked to find it when x equals 8. So in that particular case, it's going to equal -2 on top of 9 times 8 squared, which is equal to -2 on top of 9 times 64, which is -1 on top of 9 times 32, which is -1 on top of 9 2s are 18, carry 1, 27, 28. So -1 on top of 288 centimeters per second. And that's going to be the rate.